Hello and welcome to this video. In this video we will learn about theory of arithmetic, geometric and harmonic means, and we will also solve problem number 1 to 10. In the next slide we will solve more problems of these. So first we discuss arithmetic mean. Let's say there are two quantities a and b. This a is small a and capital A is the arithmetic mean between them. Then by definition, small a, comma capital A, comma B will be in AP. Now since these three are in AP, common difference will be capital A minus small a is equal to B minus capital A, which will be equal to D, but we have not written that because we don't need it. So from this equation, we can say that capital A is equal to A plus B by 2. Now the question is, if there are n arithmetic means A1 to an between a and b, then how we find them? So the series small a comma capital A1 comma capital A2 up to capital N capital AN comma B will be in AP. So now you can see that there are n plus 2 terms here. So B will be first term, which is small a, plus n plus 2, which is number of terms, minus 1 into D. So common difference would be b minus 1, sorry, b minus a, not 1. B minus a, it is a typing mistake. B minus a by n plus 1. Once we have found D, we have the first term a, we can find capital A1, which will be a plus D, which on solving the equation, by putting this value here, we get n plus b by n plus 1. A2 is a plus 2d, which will be a into n minus 1 plus 2b divided by n plus 1. Capital An will be a plus nd, which is a plus nb by n plus 1. Geometric mean. So we again take two numbers a and b. These are positive numbers, and we let capital G to be the geometric mean between them. So small a capital G comma b will be in GP. Since these are in GP, we can write that G by A is equal to B by G, which gives us G is equal to square root of AB. Now to find n geometric means, we have considered A, G1, G2 up to Gn, comma B in GP. We let R to be the common ratio. So clearly we can observe that B is n plus 2th term. So B is equal to AR to the power n plus 1, which means R will be b by a whole to the power 1 by n plus 1. So G1 would be AR, which is equal to A into common ratio. G2 will be AR square, which will be A into common ratio squared. That is, the power would be 2 by n plus 1. And so on, we can find the Gn, which is AR to the power n, is equal to A into b by a whole to the power n by n plus 1. Geometric mean can be found similarly like arithmetic mean. We just have to take the reciprocals. So we let the two quantities be A and B and capital H be harmonic mean. So A, capital H, comma B will be in harmonic mean, harmonic progression. That means 1 by A, 1 by H and 1 by B will be in AP. This is also a typing mistake. It is in AP. So we can write 1 by capital B. Oh, this is also another mistake. This should be capital H. 1 by capital H minus 1 by A is equal to 1 by B minus 1 by capital H. So from here, capital H would be 2AB by A plus B. Now we take H1 up to Hn as the harmonic mean between these two quantities. So 1 by A, comma 1 by H1, comma 1 by H2 up to 1 by Hn, comma 1 by B will be in AP. Similarly, we can find a common difference as A minus B by AB into n plus 1. So now we can find 1 by H1, 1 by H2, 1 by Hn and so on, and thus we can find the n harmonic means. Now we see what is the relation between arithmetic mean, geometric mean, and harmonic mean. We take two quantities A, B, and we assume that capital A, G, and H represent the arithmetic mean, geometric mean, and harmonic mean respectively. So arithmetic mean is equal to A plus B by 2, geometric mean is square root of AB, and harmonic mean is 2AB by A plus B. So we can quickly observe that A into H is equal to AB is equal to G square. So we can write this as G by A is equal to H by G. So A, G, and H will be in GP. Now A minus G is equal to A plus B by 2 minus square root of AB, which gives us square root of A minus square root of B whole square by 2, which will be always greater than 0 because we have assumed A is not equal to B and both are greater than 0. So A minus capital G is greater than 0, that is A greater than G. Now we also have that H by G is equal to G by A. That means H by G will be less than 1, which implies that A greater than G greater than H. Now if A is equal to B, we can prove that arithmetic mean is equal to geometric mean is equal to harmonic mean. So now we move on to problems, and as always, you should not watch the solution to start with. When the problem is being stated, you should pause the video and you should try to solve the problem yourself. If you cannot solve it, then you should look further into the video. Problem number 1 says that if n arithmetic means are inserted between 20 and 80 such that first mean is to last mean is equal to 1 is to 3, find n. So we let n means be x1, x2 up to xn. So there will be 20 comma x1, x2 up to xn comma 80. These will be in AP. So there are n plus 2 terms. That's why we can write that 80 is equal to first term plus n plus 1 into d. So d is 60 by n plus 1. Now x1 is equal to 20 plus d, which is nothing but 20n plus 80 by n plus 1. We substitute the value of d over here. And x2 is equal to 20 plus nd, which is nothing but 20 plus 80n by n plus 1. Now we are given that x1 is to xn is equal to 1 is to 3. So 20n plus 80 by 80n plus 20 is equal to 1 by n. So we solve this to get n is equal to 11. Problem number 2 says that prove that the sum of n arithmetic means between two given numbers is n times the single arithmetic mean between them. Mean is missing. So single arithmetic mean would be a plus b by 2. Now we let n arithmetic means to be x1, x2 up to xn. So a comma x1, x2 up to xn comma b will be in AP. So x1 is a plus d and xn is equal to a plus d. Sorry, this is a mistake. Xn would be a plus nd, right? Not d. So x1 plus x2 plus up to xn is equal to n by 2 into a plus b. That is sum of n terms is equal to n by 2 into first term plus last term. So here first term is x1 and xn is the last term. So sum would be n by 2 into x1 plus xn. So when you sum x1 and xn, that will be equal to sum of a plus b. So now you can clearly see that this value n by 2 into a plus b is n times a plus b by 2, and that's how we have proved the desired condition. Problem number 3 says that between two numbers whose sum is 13 by 6, an even number of arithmetic means are inserted. If the sum of means exceed their numbers by unity, find the number of means. So we let 2n to be the number of means inserted between two numbers a and b. So sum of these two means would be a plus b by 2 into 2n. Okay. Now this is equal to a plus b into n. This you can find from the sum of an arithmetic progression formula. So now this is equal to a plus b into n. Now a plus b into n is also one more than the number of means, that is 2n plus 1. That means 13 by 6 is equal to 2n plus 1. So we arrived at the value that 2n is equal to 12. Problem number 4 says that for what value of n, a to the power n plus 1 plus b to the power n plus 1 divided by a to the power n plus b to the power n, where a is not equal to b, is the arithmetic mean of a and b. So we let the arithmetic mean to be a plus b by 2. Now it is given that a to the power n plus 1 plus b to the power n plus 1 divided by a to the power n plus b to the power n is equal to a plus b by 2. Sorry about that truck horn. Now we solve this to get a minus b into a to the power n minus b to the power n. This is not 2, this should be n is equal to 0. Since a is not equal to b, a minus b won't be 0. To the power n minus b to the power n will be 0. So we get that a to the power n is equal to b to the power n, which gives us n is equal to 0. Insert 4 geometric means between 5 and 160. So we let x1 up to x4 be the 4 geometric means. So 5 comma x1 up to 160 will be in GP. So 160 is equal to 5r to the power 5. That is r is equal to 2. So the means would be 10, 20, 40 and 80. Problem number 6 is that show that the product of n geometric means inserted between two positive quantities is equal to the nth power of the single geometric mean between them. So what we have done is we have found x1 as a into b by a to the power 1 by n plus 1, where a is the first term. B by a to the power 1 by n plus 1 is the common ratio, because there would be n plus 2 total number of terms in the GP, with a being the first term, b being the n plus 2th term. Similarly, we have found x2 and up to xn. So we multiply each of them, we get it as square root of ab to the power n. But the square root of AB is nothing but geometric mean. So we have proven that product of all other means is n is equal to nth power of the geometric mean. Problem number 7 says that insert 6 harmonic means between 3 and 6 by 23. So similarly, we can take the reciprocal and then we proceed, and we get d is equal to half by following the given values. And once you have d, you can find the corresponding harmonic means. If the arithmetic mean and geometric mean between two numbers be 5 and 3 is respectively, find the numbers. So we take two quantities a and b. Arithmetic mean is a plus b by 2 is equal to 5. That is a plus b is equal to 10. We let the common ratio as r, and 3 is gm. So a 3b will be in gp. AR would be 3 and B will be AR square. So sum of A plus B is 10 here. So we substitute the value of B, we get A plus AR square is equal to 10. Now from the formula for geometric mean, we get AR is equal to 3 is equal to, this implies that now we divide this A plus AR square equal to 10 by AR is equal to 3. So we get 1 plus R square by R, gets cancelled, is equal to 10 by 3. From this, we have a quadratic equation which gives us two roots, 3 and 1 by 3. So upon substituting this for a or b, we get the desired sum as 9, 1 or 1, 9. Problem number 9 says that if the arithmetic mean between two numbers be twice their GM, show that the ratio of numbers is 2 plus square root of 3 is to 2 minus square root of 3. So we let the arithmetic mean be capital A and geometric mean be capital G between two numbers a and b. So capital A is equal to a plus b by 2 and G is equal to square root of ab. We divide both of them to get a plus b by square root of ab is equal to 2 by 1. Then we do componendo and dividendo. We get square root of a plus square root of b by square root of a minus square root of b is equal to root 3 by 1. Now we do componendo and dividendo again. We get the final answer as a by b is equal to 2 plus square root of 3 by 2 minus square root of 3. Problem number 10 says that if a be one arithmetic mean and g1 and g2 be two geometric means between b and c, prove that g1 to the power 3 plus g2 to the power 3 is equal to 2abc. So we let a is equal to sorry, what is it? Oh, arithmetic mean. A is between B and C. So A is the arithmetic mean between B and C. So A is equal to B plus C by 2. We let R as the common ratio. Then G1 is equal to BR and G2 is BR square. So we compute the cube of these two. We get BR whole to the power 3 plus BR square whole to the power 3. We take out B cube R cube common. So 1 plus R cube remains in the bracket. Now from these two we can say that R cube is nothing but C by B. And then we have this particular equation by substituting for R cube inside and outside. And then on simplification we get this as 2abc. Here I have substituted B plus C is equal to 2a. With this we come to the end of this video, and I hope you have enjoyed this and found it useful. If you think this video is useful, then please subscribe to the channel and like the video, because that motivates me to make more such videos. Thanks a lot for watching.